Okay, so this is part 2, and let's get started. I'm going to make sure this is, I know the focus has not been great. There, that's the best I can do, you guys. So I apologize for the lack of clarity, but I think it's going to get the job done. So, now you're going to see, come on, OCD's kicking in, there we go. That's the best I can do. So, part 1, we just talked about how many cycles can you fit in 2 pi. And now you're going to realize why that's important. You're going to be given problems like this, and you're going to have to make the necessary adjustments. So it says, okay, here's your parent function, and it's stretched vertically, so it's talking about the letter A, by a factor of 2. So the first step we're going to make is, we're going to put the 2 in for A. Not too bad. Then it says, and I think this is the hard part, well, let's go ahead and tackle the easy part first. Well, nope. Makes 3 complete cycles in the interval 2 pi. Now remember, the normal sine function, whoops, that looks like cosine. If I was to go like this, it looks like this. Okay, ish. So now look at it. It says makes 3 complete cycles in the same original sine of x function. That means it's horizontally stretched. That means it's literally going to go like this. I mean, that's a terrible drawing. Don't, count it perfectly. But what I'm saying is, in order for that to happen, my original formula for period is 2 pi all over the absolute value of b. Now remember, we are horizontally shrinking the original. That means we have to make a decision. Should there be a whole number down here, or should there be a fraction? So you can lock into rules. Think about this. If I had like 1/2, actually 1/3 to connect to this problem, or 3, which one is going to shrink this? The 3 is. The 1/3 would actually multiply by 3, so that'd be 6 pi. It would horizontally stretch it. This language is saying shrink it, fit 3 of them in the original period. So this is our b, not this. All right. So what do? Well, we put a b in right here, so we go y equals 2 sine. Now here comes the new language. 3x. Okay, that's so far, so good. But now it says, and I'm going to ignore this for a second because that's too easy. And it's shifted right. Now what I'm trying to do is connect this whole c over b language for you guys. So it's right pi units. So if we think about that, we're going to go, okay, how do we make an adjustment here? Well, this is where the new fancy talk is going to come into play. So we're going to have our 3 times x, and then right means negative pi. And now we're going to go up 4. And that's how you're going to use your new-ish language. All right, let me pause that. All right, so I almost did not include this example, but I'm going to be glad I did, I think. So this is just another crack at it with a little subtle changes. So how do we do this? Well, we look at this and we say, okay, our parent function is definitely sine, so we're going to go through like this, and there's 1 cycle of our normal sine parent function. Now let's make the adjustments. I'm going to start out with the amplitude because that's pretty easy. So that went down to -1, now it's -2. This goes up to 1, so that has to go up to 2. All right, that should be pretty easy by now. Now we've got something going on here, but we've learned that this, we can just concentrate on this for our phase shift, and that's going to be right pi over 2. And so now I'm going to take this thing, and so that's 3 pi over 2. This is -3 pi over 2. That's going to require us to move it over here. So why don't I transition to a different colored marker? So now this is going to go, this is going to go here, this is going to go here, this is going to go here, so I can see my loop. This is going to go, this is supposed to be -2, and this is supposed to go here. So we have moved it right pi over 2. And we used our blue marker for that. Now here it comes. The grand finale, we'll do in green. What is this? Well, if I did distribute this through, it would stick the 1/3 next to the x. So we can say, b is 1/3. So that's for this formula, 2 pi all over the absolute value of 1/3. We don't have to worry about that because it's positive, which means we got to multiply this by 3. This turns into a reciprocal, and then we multiply, so we get 6 pi. Now, here's the thing. What we're going to do now is we're going to take a look at this, our last step right here. If you notice, if we added 3 pi over 2 plus negative pi over 2, our normal period is 2 pi. Now, how do we actually move this so that we have 1 cycle in 6 pi? Well, that means we're going to need 3 pi on one side and 3 pi on the other. Now, I hope this doesn't confuse you, but I'm going to draw a vertical line right down the middle, not perfect, but right down the middle. So that means we need 3 pi on this side. So that'd be 3.5 pi. So look at, so this would be 2 pi, this would be 5 pi over 2, this would be 3 pi, and we need to go one more half, and that's 3.5 pi, or 7 pi over 2. So what we're doing now is we're stretching this to here. Notice this window, that peak is halfway between our window here. And so we need to do the same thing between our center and here. So that would be, we need to go 3 pi, and so half of that would be 1.5 pi, which would take us right here. So we move that here. Did you guys notice I was struggling with that a little bit? And then we need to duplicate that, but we have to be careful. If we go 3 pi to the left of pi over 2, we're going to end up at -2.5 pi. So here's -2 pi, and there's -5 pi over 2, which is -2.5 pi, plus the half pi gives us our 3 pi. So this blue needs to be stretched in between here. So once again, what's the halfway place? Well, 1, 2, 3, 4, 5, 6. I just need to go 3. 1, 2, 3. So I need to move that here, and that would go here and here. So there, we horizontally stretched it by a factor of 3. So we changed it from 2 pi to 6 pi. And yeah, that's a little challenging. It's not easy. All right. So I got one more thing to show you, and we're going to call this video good. All right, guys. So here we go. Couple reasons why I want to finish with this. Number one, we haven't looked at cosine yet. Number two, there's a zinger that just pops up in here. Just when you thought you had your, all your ducks in a row, math. All right. With that being said, what does y equals cosine look like? And we're going to do one cycle just so our brains can wrap our brains around this. So cosine, I focus when I teach my classes, the O. In other words, it goes over the origin, so that just gets us started. Whoops, that's supposed to go down. -1, and then this goes like this. All right, yes, this keeps going. Yes, this keeps going. But we're going to look at one simple period of our cosine function and then make our adjustments. So, first thing I'm going to do is attack this. So, any peak of 1 goes up to 3. Now you don't add 3 to here, you multiply it by 3. A lot of students add 3, but we multiply the 1 by 3, so it goes to 3. So that goes here. I love these zeros. -1 is going to go down to -3, so that drops down to here, ish. And now I'm going to make this dotted, indicating to you all that I'm not done. Now, in black marker, I'm going to focus on this. Now here comes the doozy. What in the world? Like, it used to be like pi over 2 or pi over 4, which is just a full unit, a half a unit, and our brains can adapt. And now it says 1. Well, don't lose track. These are radians. So 1 radian to the left. So you got to use your noggin. This goes back to like the first, like Pre-Calc A stuff. What is 1 radian approximately equal to? Well, if you were listening, it's approximately equal to 60. It's a little less. It's like 57, 58. But that just means if this is 90, we need to move it 60, which is 2/3 of a chunk. That's a little twist. So we got to take this green one and move it 2/3. So I'm going to focus on this. Goes here, here, 2/3, here, 2/3. This was here, so 2/3. This was here, so I need to go 2/3. So I am to right here. So to eliminate all that confusion, you guys can rewind the video if you want to take a look at where we went from point A to B, but we are to here. So I'm going to even get rid of the original. So we're to there. So we could move that thing up too right now, but I'm going to save that for the end. I want to concentrate on this. So that's our B. So remember, our period formula is 2 pi all over the absolute value of B. Because it's positive, we don't worry about it. Very rarely are they going to make that negative, which remember, reflects it over the y-axis. I think math just decides enough is enough. They rarely make B negative in this situation, but we got to put it over pi. So it's like, well, wait a minute. So the period is now 2. Now, that's interesting, because what is this? Well, this is 2 radians, which is going to be difficult, because remember we said the normal period is 1 radian is 60 degrees, so 2 radians is approximately 120. And remember, the normal period is 2 pi, which is 360, which you can kind of say, oh, it's 1/3. So we need to squeeze this thing in a lot. So we're going to bring this in okay, so 1/3 of it. So we know right now that this goes from negative pi over 2 to 3 pi over 2. If we look at that, we're like, hey, that's 2 pi. 3 pi over 2 plus negative pi, or just 3 pi over 2 plus pi over 2 is 2 pi. So we got to shrink it down into 120. So really this needs to come, there needs to be 120. So I'm going to draw a line right down the middle, which means 60 to the right of that, which is approximately here. Notice I'm saying approximately, 60 here. And now I need to just draw that thing into the best of my ability. And now it was horizontally shrunk by pi, which that one's a doozy. All right, so good luck on your homework. And I think I stopped that a little early, but notice I used my powers of estimation. This in between here should be approximately 120 degrees, 60 to that side, 60 to that side. I hope that makes sense, because when this was 2 pi, we needed pi on this side, 180, pi on this side, 180, 360. Same thing here, just shrunk. I hope that helped. If you like the video, like and subscribe. Thanks, Ryan Sheffer.